Hi, this is George in Professor Wellman's CSC 110 class. And this week our YouTube assignment was Chapter 6, Problem 13. And exercise 13 asks us to write a function slope with the parameters x1, y1, x2, y2 that returns the slope of the line through the points x1, y1, and x2, y2. And be sure your implementation of slope can pass the following test. So one of the things that chapter 6, a lot of their exercises, they want you to run this test suite just to kind of learn about unit testing. So if you go to the top of the exercises for chapter 6, you'll see it says all of the exercises below should be added to a single file. In that file, you should also add the test and test suite scaffolding functions shown above, and then as you work through the exercises, add the new test to your test suite. This is what they're kind of talking about with the test suite thing is on page 78. They just kind of talk about unit testing, and they make this test function and they couple that with let me see. Yeah, the test function and the test suite, and pretty much this is how they just want you to be testing your functions out like as you go. It's a good practice for software development. All right, so let's get into problem 13. Let's see how we do it. It's also a two-parter. The second part we use that slope the first function we make, the slope function, as a helper function inside this new one called intercept. And intercept actually has the same parameters, and what intercept does is it just returns the y-intercept of the line that passes through those 2 points that are parameters. So here's my code here. Line 1, I'm importing sys, and that's, once again, that's part of the unit testing type of thing. That's part of those functions that we make for the unit testing. This here is my slope function, and that just returns the slope given the coordinates of 2 points, x1, y1, and x2, y2. And how I did that is I defined the rise, because if you recall from those early algebra days, the slope is equal to delta y over delta x, or rise over run, is how we always remembered it. So I just called this rise, and that's y2 minus y1, and that's equal to delta x, and run equals x2 minus x1, and that would be delta x. I'm sorry if I said rise is actually delta y, if I messed that up. And then I just want that slope function to return rise over run. And I could actually, when I was writing this, I was kind of testing it as I go with that test suite. So as I was writing it, they want it to be sure your implementation of slope can pass the following test. So I ran that after I wrote the slope function just to make sure that it works before moving on to the intercept function. And that's kind of the whole point of that. Like, they want you to get in the practice of testing your code as you go. So that this test function is part of that unit test, and this line right here just kind of gets the line number of our file here, like, and if it passes, it's going to display this message and test that line, whatever that line number calculated is okay if it passes the test. And if it doesn't pass the test, it's going to tell you it fails, and it'll tell you exactly what line it failed at. So that's very helpful. So let me just kind of rearrange this so it makes a little bit more sense. There we go. So that was part one, the slope part. And part two, they wanted the intercept. They wanted to find the y-intercept with this intercept function. And if you recall, slope-intercept form is y equals mx plus b. And what I did was I just solved for b. And I said, I just subtracted that mx part over to the other side. So it would be what this pretty much says, this side of that says like y minus mx, and that would be y1 minus our slope function, is because m stands for slope in that slope intercept form. So this would be m. I could write it out like kind of stack that more like m equals our slope function. I just kind of did it to save some space here. Just put it all in one line. So also in that slope intercept form, we can plug in either or of these points. We could have done y2 and x2 over here, but I just chose y1. It's either way, you're going to get the same answer for your y-intercept, and then we're going to return that b for the y-intercept. And here's our test function, and then the test suite is I'm like they want it to make sure that it's able to get these same answers here. It's pretty much just saying like run your function with these parameters and make sure that the output is 1.0 if your parameters are 5, 3, 4, 2, and so on and so forth. And same thing with the intercept. This whole testing thing is saying like make sure when you run your intercept function, your parameters 1, 6, 3, 12 give you 3, like it would give you that. And so when I plug that into my test suite, it'll output either okay or failed. And I'm just gonna show you that my functions are okay here. I'm gonna run this module. Save that, and let me bring the shell in here. Yeah. Okay, so as you can see, test at line 27 through 33 is okay, and so that would be, this would be 27, and that would be line 33 there, and everything worked out. It works exactly as it should, and that's what that testing is telling you. And if it didn't work out, it would have said test at line 30 failed if for some reason at line 27, 28, 29, 30, if for some reason I wrote the function wrong and it was giving me a number other than 2.0, like it would have said failed here. Let me just show you that too. To see that I changed that to 3.0, and we know that's not the truth if you worked out the math. And it just would be telling me that line 30 is a failure, and that would help me debug my code. So I'm just going to change it back real quick. Alright, that was chapter 6, problem 13. Thank you for tuning in. Have a good day. Bye-bye.